In this example, we have 5 to the power of 3x equals 16. So, I checked that I have one part on the left side and one part on the right side. So, since x is the variable and it's in the exponent place, so we're going to do log on both sides in order to solve for x. So, log of 5 to the power of 3x equal to log of 16. So after that, I'm going to use the power property. I'm going to move my exponent, which is the 3x, in front of the log. So I actually have 3x log of 5 equal log of 16. Next, in order to solve for x, what I'm going to do first is I'm going to divide both sides by log of 5. So what I'm going to have is 3x equal log of 16 over log of 5. Now, if you're working with a calculator and you're just simply solving for x, then the next course of action would be just to get x by itself. I'm going to divide both sides by 3. Now, since I actually have a fraction in the top part, x is equal to log of 16 over log of 5. This whole part is in parentheses over 3. And that's what it would be if you're just simply solving for x without calculator. Notice how I put the top part in parentheses so that I want to say that the numerator, the log of 16 and the log of 5 are part of the numerator and it's separated from the 3 where the 3 is the denominator. So this is where I would stop if I'm just simply solving for x without a calculator. Now, if you are trying to evaluate what is the value of x, so what you would do is evaluate log of 16 over log of 5. So, if you're evaluating for x, instead of dividing by 3 here, what we're going to do is evaluate what is log 16 over log of 5. So, what we're going to do is we're going to erase this to make room. But again, this will be the answer if you just solve for x without the calculator. Now we're talking about the portion when we're working with the calculator. So, what's going to happen is when you evaluate log 16 over log 5, here you don't have to worry so much about parentheses because we're just working with a single log in the numerator and a single log in the denominator. What you're going to have is 1.7227, and I'm just going to end with 4 decimal places. Next, in order to solve for x, here I'm going to divide by 3. So x is going to equal, or approximately, since we're working with decimal, 0.5742. And again, when working with decimal, I'm going to be approximating. So, again, I did log 16, close parenthesis, divided by, because again, I want to keep this separate from the denominator, log of 5. I had this long decimal number, but I just round to the 4th decimal place, so 1.7227. Then I basically divide by 3, 0.5742. So that's what we're going to have. Again, I just only stop to the 4th decimal places. You don't have to write the whole decimal. That's just too much work. I'm asking it's just to the 4th decimal place. Now, to check if it's the correct answer, we're going to see what we're going to get when we plug it back in. So I'm going to write on the side here, x is approximately 0.5742. I'm going to erase this to make room. And then we're just going to plug it back in. And you're going to see the purpose of finding the decimal answer because we were solving for x. So it's 5 to the power of 3. So instead of x, we're going to plug in 0.5742, close parenthesis, and supposedly it's equal to 16. So what's going to happen here, I'm going to multiply the 3 to the decimal. So 3 times 0.5743. Now we're back to 1.7227. I'm not going to write the long decimal. I'm just going to stop at the 4th decimal place. So 1.7227. So now it's going to be 5 to the power of 1.7227. And supposedly it's equal to 16. Next, I'm going to raise 5. So I'm going to put this to raise it to the power of 1.7227. I'll just stop at the 4th decimal place. I'm not going to put the whole thing. Hit enter. I get 15.9998. So let me write that out. So 5 to the power of 1.7227 is 15.9998, which is closely to 16. So that means that our answer is correct because it's very, very close to 16. So this is good. So we know that our answer works. So let me box that up. So that's how you double check if your answer is good, the value of x. Since I plugged in the value of x, multiplied to the 3, which I got 1.7227 for the exponent, raised 5 to the power of 1.7227, I got 15.9998, which is very close to 16. That means our answer is good. So again, this is how you double check. And this is the reason why we're doing all the logs to solve for x when x is the exponent.